class. In this lesson, section 9.6, we're going to take a look at some geometry concepts with symmetry and tessellations and translations. A tessellation is a rigid motion on which we move a geometric object. So if I was able to grab this shape and slide it over here, we describe that with a tessellation vector. In other words, this is just the easiest way of saying it. It's telling you you're going to go down 5 over 10 or something like that, is what your tessellation vector be called. That's everything that we need on that slide. So this says construct a reflection. So we'll start with reflections, and we'll get actually into other tessellations or translations, moving things. Here it says that we are going to take and reflect about line N. So line N is the x-axis, and so our job is to basically take this triangle and flip it. Now whenever you move a shape, I want to take the dots and actually translate them properly, and down here you can see an A prime happening. Because here's what's happening. If I count this out, I got negative 1, 2, 3, 4, 5, and then I go up 1, 2, 3, 4, 5 places. A right now is at 5, 5. To reflect it about N, what I need to do is do the opposite of the, not the x value, the y value. I apologize, I circled the wrong thing. And so if I do the opposite of the 5, and go down 5 instead of up 5, I will be exactly where A prime needs to be. So I'm over at 5, but I'm at negative 5. And that reflects it across this line. Okay, so that's where A prime is going to be, so I need to do the same thing with B. B is at negative 2, positive 2. This one was at negative 5. I put a positive 5. It's terrible. Negative 5, negative 5, negative 5, positive 5. Anyway, back over here. Negative 5, 2. So you go left 2, up 2, and our job is to reflect it across the x-axis, so I just need to flip exactly down to be right here, and this will be my B. You put the little mark up there, it's called B prime, and this is at 2, negative 2, negative 2. So you're just reflecting, doing the opposite. By reflecting, you're taking the opposite of the coordinate. And then here's C. I want to reflect it across that line, so you go exactly however far it was up, you go that same distance down. So now I'm right here. This will be my C prime, my new C, which is at negative 1, 2, 3, 4, and down 1. So a couple ways to describe what I'm doing here. I do need to actually draw this shape in. So I'm going to draw it in green. So this is my reflected shape. So basically, wherever your line is, it's like if you folded it right across this line, these triangles would match up perfectly. So really all that happened was I took this distance, which was 5, and I went down that same distance. This distance was up 5, I go down that same distance. This distance was up 2, I go down or across the line that same distance. That's how you reflect something. Okay, so here it says reflect figure B about line L. So now here we're actually going diagonal. But it's not as bad as it may seem. Here it's not going to be looking at a distance, it's looking at 2 directions. So I'm going to be from this point on the line, I'm 1, 2 places over, 1 place up. So I'm going to do, in other words, I'm going to the right and then up. I got to reverse those directions. I don't just go left and down. It's actually down 2 and then over 1. And that would see, maybe you can see that that would be if I rotated it exactly there. So instead of going right and up, I go down, then left. Okay, and then here I do the same thing. This would be right 2 and up 1. So I go down 2, left 1. So this dot is now reflected right over there. So what I'm doing is this is my first side. You can see that it's equidistant from my line. Okay, and then I've got this point up here, which if I want to measure it, it's just basically 1, 2, 3 dots away. In other words, 2 diagonals away from this dot. So I can actually just do that, measure it like this. Same thing over here, 1, 2 diagonals away from this dot, 1, 2 diagonals away. And you can see my shape is just cutting in, so I want to cut in that same direction to reflect that shape. So I got lots of different marks there. Bottom line is this is my new shape drawn in. That would be if I folded this back up, folded this whole graph along this line, you would see that those would match up. Okay, so bottom line, I got to go the same distance away from the dot. So you saw I went down and over. Maybe that was confusing. Another way to look at it would be you can go this half diagonal distance out, another full diagonal distance out. So you do the same thing here, half a diagonal, full diagonal. This is where that dot should be. Same thing here, full diagonal, half a diagonal, full diagonal. There you go. And so that's exactly where that shape should be matching up. Two diagonals, and then a little cutout. Maybe that was a little bit cleaner way of explaining that. So that's how you do a reflection. Basically, every point needs to be the same distance on the other side of the line that it is right where it originally is. Okay? So now let's do a little bit more complicated picture of A. So A is right here. This one's kind of hard to reflect because you're not doing the whole shape. So this guy's over here, so I need its reflection point to be here. This point's right here, so I need its reflection to be over here. So I'm going to do a different color than red because that's definitely not working for me. So my shape, if I was to reflect it, this point's going to be here. This point's going to be here. This point is one diagonal, two diagonals on the other side, so one diagonal, two diagonals right there. This guy is going to be right here. This is going to be over here, and this point's going to stay exactly where it is. Okay? So now let's see if I can actually trace that. If I combine this one here, across, like that, there, and there is my shape. You can see that it's rotated. If I folded it, all these points would match up, and there is my new, we'll call it A prime. Should have called the other one B prime. There's my A prime reflected about line L. Okay? Now, this one's not reflecting. What we're asked to do here, and it looks exactly like this in your homework, it says translate the figure by vector W. Well, here's W. We're translating figure A, so we're talking about this shape right here. So vector W is just telling you, hey, take shape A, measure out what's happening here. By measure, I don't mean like find the distance here. I mean actually do slope, identify slope of W, the vector. So it's saying start at, it's supposed to be a different color marker, sorry. Start at this dot right here and count. It rises one and it moves 1, 2, 3, 4 places to the right. So our job is to take this whole shape, rise one, and go 4 places to the right. So to do that, you take every dot. Rise one, go 1, 2, 3, 4 places to the right. There it goes. So this is my new A prime top right dot. Take the same thing here. Go rise one, 1, 2, 3, 4 places to the right. Same thing here. Rise one, 1, 2, 3, 4 places. Same thing here. Rise one, go 1, 2, 3, 4 places. And last corner, rise one, 1, 2, 3, 4 places. And now I have all my A prime dots. If I connect them, we will see my new A prime shape. So this, you can see, is a mirror of the shape that we had here. It's just moved up and over the exact distance up and right as vector W. Okay. So let's take a look at the next problem, which is going to translate figure B. I'm supposed to be grabbing a pen. And we're moving it by vector V. And so vector V is a different vector. It's moving down. Erase vector A, or A. So I'm going to go down 1, 2, 3 places, then move to the right 1, 2 places. So you start, notice how I'm starting, by the way. I'm starting at the one side that doesn't have the arrow, and I'm finishing where the arrow is. So I'm going down 3, right 2. So every one of these dots needs to go down 1, 2, 3, right 1, 2. So that's my first new dot. This dot is also going to go down 1, 2, 3, right 2. Right here. Sorry, I missed that guy. And then down 1, 2, 3. Sorry, I didn't count right there. 1, 2, 3, right 1, 2. There's that dot. And then this dot here. Right. So go down 1, 2, 3, right 1, 2. This guy is going to be right there. I don't need to count it. This one's going to be 2 over from there. And then I can connect my dots. So this is going to go right there. Let's actually do it with the highlighter. So it's going to go right there, here, and there is my figure B. That is the exact shifting down and right. So down 3, right 2. So this is how we translate using a vector. Okay. Now, you have one problem in your assignment where you actually have to shift a vector, shift by two vectors. That's what I'm trying to get out. I'm trying to get my pen. Okay, here we go. So now it says translate figure A by vector V. Call that resulting shape A prime, and then translate the new figure A prime by vector W. Call that resulting shape A double prime. In other words, it's going to get two shifts. So we take A, and we're going to shift it by this vector. So we take all these and go down 3, 1, 2, 3, over 1, 2. So if I do that, and then if I do that for all my points, down 1, 2, 3, over 1, 2, and then what I can see is I can probably just draw my shape in from there if I match up exactly what A was, rather than having all my accounting happen for you again. Hopefully you got the point so far. So this is my new shape A prime, and that's by shifting this vector V. Okay? So from there, it's saying take that new shape A prime and shift it by vector W. In other words, take all these new dots and go up and over with them. So I'm going to go up 1 and over 1, 2, 3, 4 places with them all. And you can see I'm just going to kind of drag all these dots up and over by just kind of matching up the shape to make it a little bit quicker here for us. And so this is my new shape, up 1 over 4, and this they want us to call A double prime. So you will be doing exactly the same process in one of your assignment questions. So let me know if you have any questions through the Ask My Instructor feature below.